All right, question 2 says the exothermic dissolving of scandium-3 fluoride is represented below. Which of the following would decrease the concentration of the scandium ions? So you're trying to make the amount of scandium ions go down here. All right, so if you're going to make the amount of scandium ions go down, then what you are doing here is, this is just a Le Chatelier's, you are basically sending it over to the left-hand side, because that would cause this to go down, and this to go up. So basically what you're doing is you are looking for which of these is going to cause the system to go to the left. Now it said it was exothermic. So if it's exothermic, that means heat is on the right-hand side over here. Okay, so which one of these is going to make the amount of scandium go down? All right, well, would adding scandium nitrate make the scandium go down? Well, no, because the scandium nitrate is going to be the scandium plus 3, and then the nitrate ions that are there. So that's going to make the amount of scandium go up. Yeah, it's going to send it over to the left-hand side, but again, if you're talking about a saturated solution, that's not going to change the amount of scandium that's there. You're going to make the scandium go up, and then you're going to make it go back down again because it's going to go over to the left. So that's not your guy, all right? Don't forget that heat was over here. Okay, if you decrease the temperature, so that is going to decrease the temperature, that's going to send it to the left. Now that's going to make the scandium go up, so that's not what you want. That's no good. All right, well, what about adding in 0.1 molar nitric acid? Well, let's see, what does nitric acid have to do with this guy? Technically, nothing, but the short answer is nothing. But until we get involved with the idea of acid-base properties, we're going to ignore the fact that this is technically going to have an effect on this, but it's not going to be an effect that we know about. And since we don't know about strong acids and weak acids yet, we're just going to ignore this guy, because technically he has an effect on this, but I'm not going to get into it. Because the better answer here is the KF. Now, you look at this guy up here and you say, well, KF is not involved up here, right? But he actually is, because adding in solid KF would add in K plus 1 and F negative 1, because, again, that is soluble. So what that's going to do is that's going to raise the amount of fluoride, which is going to send the reaction over to the left-hand side, which should decrease the amount of scandium. So that is